You have a semantic model in Power BI containing 4 queries: Query 1, Query 2, Query 3, and Query 4. Query 1 retrieves customer data and serves as the source for the other 3 queries. You notice that the dataset refresh takes too long. You need to optimize the refresh duration while keeping costs to a minimum. What action should you take?
Option A. Apply the table.buffer function within Query 1. Option B. Copy Query 1 so that each of the other queries has its own duplicated source. Option C. Convert Query 1 into a data flow entity. Option D. Scale up the capacity settings via the Power BI admin portal.
Let us consider what this scenario is asking. When working with Power Query, a single query often acts as the foundational source for multiple downstream queries. If that base query is not managed efficiently, the underlying data source might be hit repeatedly during a refresh. We need to think about how Power Query evaluates referenced queries, how to optimize performance without incurring extra costs, and which of these options directly addresses query evaluation behavior.
In my view, the correct answer is option A. Apply the table.buffer function within Query 1.
When a query is referenced multiple times in Power Query, such as Query 1 being referenced by Query 2, Query 3, and Query 4, Power Query can evaluate the query multiple times against the data source. This leads to slow data refresh times. Running the table.buffer function on Query 1 forces Power Query to load the table into memory once and reuse it for subsequent references, thus improving performance.
Options B and D do not solve the multiple evaluation issue efficiently or cost-effectively. Option C, using a data flow, could help, but data flows typically require premium capacity or incur additional architectural overhead. Meanwhile, table.buffer is a zero-cost, code-level optimization that satisfies the requirement to minimize costs.